This video lesson is on 6.7, which is probability and odds. Now there's a lot of vocabulary for this section, so it's really critical that you take the time to write all these vocabulary very neatly in your notebook, because it's going to take some time to learn this vocabulary and keep track of what they're asking for. So let's go through them together. So the outcomes are the possible results of an experiment. So for example, if you're flipping a coin, there's two possible outcomes, heads or tails. If you are rolling a six-sided dice, there's six possible outcomes. 1, 2, 3, 4, 5, 6, and 6. An event is an outcome or a collection of outcomes. So if we were to flip this coin 10 times, we'd be collecting 10 different outcomes. That's considered an event. Now, favorable outcomes. These are the outcomes for a specified event are called favorable outcomes. So for example, if I said that the favorable outcome is heads, then anytime it lands on heads, that would not be a favorable outcome. So we can make a tally here. What if we flipped it again? We got tails again. That's an unfavorable outcome. Let's flip it again. Heads. So in this case, I got a favorable outcome. The probability that an event occurs is a measure of the likelihood of the event occurring. So for example, the likelihood that it lands on heads, the probability of that is 1/2, because there's two sides. So the probability is 1/2, or 50% probability that it's going to land on heads. Theoretical probability, now we're going to specify probability a little more. So theoretical probability is based on knowing all the equally likely outcomes of an experiment. So, for example, the theoretical probability is that I will land on heads an equal number of times that I land on tails. An experimental probability is when you actually do repeated trials of an experiment. So in this case, if we do this a few more times, we got a tails. Let's do it again. We got a heads. Heads. Tails. We'll do it 10 times quickly. Heads. 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 So in this case, when we actually flipped it 10 times, our experimental probability says it's 6-4 heads to tails, which can be simplified to 3-2. So our experiment tells us it lands on heads more often. Now, the more times you flip the coin, the more accurate it's going to get. So you need to keep track of that, but we'll discuss that later. The last two are odds in favor, and it's the ratio of the number of favorable outcomes to the number of unfavorable outcomes. It's called the odds in favor. And odds against is the ratio of the unfavorable outcomes to the number of favorable outcomes. It's called the odds against an event. So that's actually what we did here. So the odds in favor, if we wanted heads, would be 6-4. The odds against would be 4-6. And actually, if we're talking about probability, experimental probability, we said we want to find the probability that it's going to land on heads in the experiment. Well, in this case, it was 6 out of 10 times, or we can divide that, or it's equal to 3/5 of the time. Where here, a theoretical probability of it landing on heads equals 1 of every 2 flips. So we'll go through these more later. This is taking a little while to do the vocabulary, but be patient. So the probability of an event. The probability of an event is the number of favorable outcomes out of the number of possible outcomes. So for example, suppose you roll a number cube over here. What is the probability you roll an odd number? Well, we know there's 6 sides. 3 of them are odd. So it's 3 out of, there's 6 possible outcomes, or 1/2. So a half of the time the probability is you will roll an odd number, the other half you're rolling even. So suppose you roll a number cube. What is the probability that you roll a number less than 5? So not including 5, just less. Try that on your own. Next is, what if it's an actual experiment? So the experimental probability of an event is the probability of an event is equal to the number of successes over the number of trials. So the number of times you successfully land a coin on heads compared to the number of times you flip it. So let's try an example using a different situation. So if you planted 32 seeds of a certain flower and 18 of them actually sprout, the others didn't sprout, find the probability that the next flower seed planted will sprout. So we do the number of successes divided by the number of trials. So 18 out of 32, and we simplify that to 9/16, which means 9/16 or 0.5625 probability that the next one is going to sprout. And lastly, try this one. A drawer contains 12 white socks, 4 red socks, 6 green socks, and 10 blue socks. You randomly choose one sock from the drawer. Find the probability that you will choose a red sock. Example 3 is, can you use probability to make a prediction? So, of the last 40 table tennis games you played against your brother, you won 16 of those 40 games. Use experimental probability to predict how many of the next 20 games you will win. So the first step is you want to find the experimental probability that you will win the game. So 16 divided by 40 gives you 0.4 of the games, or 40% of the games you're going to win. Then you multiply that experimental probability here, the 0.4, by the number of games you're going to be playing next. So by the 20 games. So 0.4 times 20 equals 8. So you'd answer, if you continue to win the same fraction of table tennis games against your brother, so you don't get any better and he doesn't get any worse, then you will win the next 8 out of 20 games likely. So we're predicting. It may not actually happen, but that's the likelihood that you'll win 8 out of those 20 games. So try this example. Of the last 25 foul shots you attempted, you made 15. Use experimental probability to predict how many foul shots out of the next 5 in the big game that you will make. So press pause and try this now. And lastly, this is the last type of example problem, which is finding the odds. Now this is using the odds in favor or the odds against. So you randomly choose a letter from a bag that contains one of each letter of the alphabet. What are the odds in favor and the odds against choosing a vowel? So how many favorable outcomes are there? So the favorable outcome is a vowel, so there's 5, A, E, I, O, and U. And then to find out how many unfavorable, there's 26 letters in the alphabet, minus 5, leaves us with 21 consonants. So for the odds in favor, it's the number of favorable outcomes divided by the number of unfavorable. So it's going to be 5 over 21. So when you add these two together, they should equal the total number of possible outcomes. For the odds against, it's the number of unfavorable divided by the number of favorable. So 21 over 5. So give this one a try, and that will end this lesson. So you spin a spinner that is divided into 20 equal parts. 6 parts are orange, 8 parts are white, 3 parts are black, and 2 parts are red. And then lastly, 1 part is blue. Find the odds in favor and the odds against spinning a white, having the spinner land on a white block. So that's all for this lesson.